Okay, welcome to this next video. Introducing the idea of rates. Okay, so again, we're sticking with the same learning goal that students can solve everyday problems involving rates, ratios, and percentages. And at the end of this, you'll want to be able to use a given rate to calculate the change in some other measurement, and lastly, to be able to calculate a rate from some set of observations. Okay, so rates crop up in science all the time. Here's some set of rates that we use in physics just to be able to communicate some ideas behind things and usually sometimes to create a different, easier unit. So for instance, energy is measured in joules, which 1 joule is kilogram meters squared per second squared, which kind of doesn't make a lot of sense maybe, which is why we kind of call it a joule. It's expressing a rate of change of energy and mass and acceleration. Okay, right. So, and again, we go to the force here. So force is a Newton, and a Newton is a rate of 1 kilogram meters per square second. Now, so you'll see that a lot of similarity there between joules and newtons. The only thing different is the meters become squared, and that's because, remember, work is energy, and work is a force times a distance. That's why we get our meters goes up to meters squared. Okay, power. Power is measured in watts, which is 1 joule per second. So if 1 watt of energy is being consumed, that means that 1 joule of energy is being consumed every second. And potential difference, which is the difference between two different electric potentials. We've got 1 kilogram meters squared per second cubed amps. I mean, that's kind of ridiculous, but we're talking about 1 joule per coulomb, okay, which just sort of talks about how much energy is it going to take to move some charge from here to here. Okay, so it's a little bit of a different and interesting concept, and it's something that if you choose to do physics and science sort of later on in your school, you might start to get to play around with some of those things, get a bit more deeper understanding. But rates happen everywhere. Okay, so rates compare quantities that have different units, so they have to include the units. So if someone was to say, oh, how fast are you going, Mr. Brady? And I just said 3,000, you would just like, whoa, are you serious? And what I actually meant was like 3,000 millimeters per second. You'd be like, oh, he's trying to be funny. So we've got to be very careful. So for instance, you might say, right, 80 kilometers per hour. Okay, so it's important that you give the units in your rates, which is different to ratios. Okay, now the units are separated by this sort of slash here, which means per. So for instance, you could pour water out at 20 milliliters per minute. Okay, so water could be pouring out of something at 20 milliliters a minute. That little per means it's sort of like a per there for us. Okay. And I'm back from sorting my battery problem out there. Okay, so similar to fractions and ratios, you should probably represent rates in their simplest form. So for example, what is that drawing there for me? For example, the car travelled 36 kilometers in 4 hours. And so it should really be sort of putting that in their simplest form. So that means that we need to find highest common factor of 36 and 4. Which is 4, so we're going to divide by 4 on both sides, and we'll end up with 9 kilometers in 1 hour, which would be 9 kilometers per hour. Okay, right. You can also calculate something called the average rate by dividing the total change in one quantity by the total change in the other quantity. Okay, so for example, I drove 60 kilometers in 4 days, so that would mean that so I would have 600 divided by 4, which is 120 kilometers per day. Okay, and that would be sort of your average rate of change. Okay, and here's another one for us to maybe think about, which is this idea. So we've got Sam Stilson here. He holds a record for crushing 56 eggs against his head in only 30 seconds. So how many eggs would you expect Sam to crush against his head in 5 minutes? So we can sort of work that out. So the first thing we do is we write the ratio as it's given to us, or the rate, sorry. So we've got 56 eggs per 30 seconds. Okay, the first thing you want to do is you think, okay, so we've got minutes here. So we know that our final idea, our final rate has to be per minute. And so we're going to think to ourselves, right, how do I get 30 seconds become a minute? Well, use that idea of 30 seconds times 2. It's going to get us our 1 minute. So if we times this side by 2, and we're going to times this side by 2, we get 112 eggs per minute now. Right, so now that we've got that, how do we get 1 minute to become 5 minutes? Well, we times by 5, and so that means we have to times this one by 5, which means 560 eggs. Okay, so a bit of a crazy guy, smashing 560 eggs on his head every 5 minutes. So we'd expect him to crush 560 eggs. Okay, now lastly, the world record for the most toilet seats broken with the head of in a minute is 46, achieved by Kevin Shelley on the set of the Guinness World Records to Großen Weltkreuz in Köln, Germany on the 1st of September 2007. Now, so we can calculate the average number of toilet seats broken per second. So let's set up our rate to start with. So it's 46 seats per minute. Right, so that changes to 46 seats per 60 seconds, okay? Because we know that we want our final thing to be in seconds, okay? And now we want to get per 1 second. Okay, so how do we get from 60 to 1? Well, we're going to divide by 60, so that means we have to get this side here and divide by 60. And we end up getting 46 divided by 60 is about 0.77 seats per second. Okay, so this guy's smashing 0.77 seats per second on his head, and that's the average rate of toilet seats broken per second. Okay, so again, as I've been saying with a lot of these videos, the number one thing you can do is sort of practice a lot of these examples to get totally okay with them, see all the different ways that things can be asked and ways of going about answering them, because as with the other ones, there's a few methods. A lot of it's whichever one you feel most comfortable with going through that process. Okay, thanks so much for watching, and make sure you ask me any questions at school with stuff.